So this is our robot Indy on the rocks, and I'm going to show you how the electrical systems work. So right here we have something called an H-bridge, and this circuit essentially is a pair of MOSFET switches which allow us to run current in opposite directions through a motor. And here we have actually the power rail, and these are actually two separate H-bridges. And this power rail powers both of these H-bridges, which each independently run one side of the robot, right? So the way our H-bridges work is we have comparators, which are taking in a 5-volt reference from the TINA, and then we also have the motor outputs from the TINA right here going through to the comparators, and these create PWM signals, which are then used to turn on the correct gates. By doing this, we allow current only going through one direction of the motor to run, and that's how we drive our robot. So let me introduce you to the motherboard. Most of our electronics are powered and controlled through this small circuit board right here. This circuit board contains the 16-volt rails that powers the motors and TINA, as well as the +8 and -8 and 5-volt rails that power the OP805 IR detection circuit, as well as our servos. For example, our collection arm servo and our zipline deployment servo. Another cool thing about our electronics is that we have a variety of switches for fail-safes. For example, we have a switch for a motor, which turns on the access of the rails to the H-bridge. So for example, when we flick this switch right here, we'll see the robot drive forward. And we can switch it off just as easily. This helped us in debugging a lot and also during testing, because it allowed us to keep the software running but stop the robot from wreaking havoc. Next we have the second switch, which controls the OP805 IR detection circuit, as well as the servos, and also includes the winch. So for example, when I turn this on, you see the servos start going. Finally, our mechanism for ziplining would be incomplete if it wasn't for our winch system. So our winch system is winching this carabiner here, which is latched onto the zip line. And the way it does that is via a MOSFET switch located right there. So when we send 5 volts to this MOSFET switch, 16 volts is run through our EPIC motor, which has, I think, about a 50-to-1 gear ratio or something like that, and is able to winch the entire robot up onto the zip line, bringing it home. So I'll show you an example of that right now. You can see it start to winch. That's our winch in action.